Hello class, welcome to Unit 4, Video 5. Today we're going to look at solving quadratic equations by factoring. We have already looked at solving quadratic equations by graphing. Okay, today we're going to do so by factoring, and we've been working on our factoring skills for the past few days. So the learning target for today is that you can solve quadratic equations by factoring. Let's just look at an example we already know how to do though. Okay, we're going to solve x squared minus 2x minus 3 equals 0 by graphing. In order to do that, we find the y-intercept, the vertex, and the axis of symmetry. Remember, the y-intercept is your c value, so it's the ordered pair 0, negative 3. We're going to find the vertex, but in order to do that, I need to find my axis of symmetry first. So axis of symmetry, remember, is the equation x equals negative b over 2a. So negative b would be negative negative 2, which would give me a positive 2 over 2 times my a, which is 1. So I have 2 over 2, which reduces to 1. So the axis is at x equals 1. So let's go ahead and plot that on here. Try and do it as straight as I can. All right, so it should be nice and straight on yours. You can use a straight edge or a ruler if you have one. Then I'm going to go ahead and find the vertex. The way we find the vertex is I take my axis of symmetry, plug it into the equation, and I'll get out my y value. So y will equal 1 squared minus 2 times 1 minus 3. So this gives me 1 minus 2 minus 3. 1 minus 2 is negative 1. Negative 1 minus 3 is negative 4. So the vertex is 1, negative 4. Let's go ahead and plot these. I have 0, negative 3. Remember that I also will have a symmetric point across my axis of symmetry. So there's my other point, 2, negative 3. And my vertex is negative 1, negative 4. Then I'm going to go ahead and sketch my parabola to find my zeros. Okay, if I look at what I have, it looks like my zeros, if you remember where they are, they're where it touches my x-axis, is at x equals negative 1 and at 3. Those are my zeros. Well, I already told you today we're going to learn how to solve equations by factoring. So let's just look at this one right here that we are given. We are given the equation x squared minus 2x minus 3 equals 0. Let's just factor it and see if I can see any resemblances. So I would say what multiplies to negative 3 but adds to negative 2. Well, the only thing that multiplies to 3 is 3 and 1. And if I want them to add to negative 2, I'd have to have negative 3 plus 1 equals 0. So I have these two values. If you notice, my answer is positive 3 and negative 1. The way that we get those values is by taking each part and setting it equal to 0. And I'll talk about why we set it equal to 0 in just a minute. And if I solve this, I get x equals 3 and x equals negative 1. There is my answer. I would also point out isn't factoring a more exact way of getting an answer? I mean, like, I could have drawn this not anywhere near 3. And now I know my answers for my zeros are correct. Also remember when we did graphing, we had answers, we would say, oh, they're between 1 and 2. This way we'll have an exact answer. We won't just have to guess where it is. So why can I take each part and set it equal to 0? The way we do it is through the zero product property. Okay, so the zero product property is for any real numbers a and b. If a times b equals 0, then either a equals 0 or b equals 0 or they both equal 0. The reason that is if I have something equal to 0, the way I get that is at some point I had to take 0 times some number, or vice versa, some number times 0 or 0 times 0 to get 0. So in our example, we're going to use the zero product property. Okay? What they're saying is if I multiply this number times this number, one of them or both of them has to equal 0. Because if I multiply, one of them has to be 0. So that's how I can say, well, x plus 5 equals 0 or x minus 7 equals 0. One of them has to. And when I solve, I get x equals negative 5 and x equals 7. So that's our zero product property. Okay. So let's go ahead and solve some quadratic equations. Okay. By factoring. Step 1, set the equation equal to 0. Then we are going to factor it completely, and then we'll set each factor to 0. And lastly, we'll solve. So if I look at 1, it's a quadratic. I want to get everything to one side. If I can, I want to keep my x squared positive. So it's really x squared. I would minus 6x to the other side equals 0. That's step 1. Check. Step 2, factor completely. This is not a trinomial. There's only 2 parts. So I'm going to look for a GCF. GCF is x, so I would have x minus 6 equals 0. It's factored completely. Check. Step 3, set each factor equal to 0. Zero product property. Either this equals 0 or this equals 0, or they both do. So x equals 0 and x minus 6 equals 0. Well, this one there's no solving, so one answer is x equals 0. This I have to do a little solving. I would add 6 to both sides, and x is equal to 6. So those would be my 2 solutions by factoring. So graphically, if this is my parabola, I know I'm going to be hitting at when x is 0 and when x is 6. And this one, my parabola is going to open up because my a is positive. So those are some values that I do know. Moving on to example 2. Step 1, set the equation equal to 0. I want to keep my x squared positive, so I'm going to move everything over to it. So I would have to subtract 5x, and I would have to subtract 14 to equal 0. Now I would factor. First I would look for a GCF. There isn't one. I notice my coefficient is 1, so I'm going to have just x's in the front. And I say what multiplies to negative 14 but adds to 5. So 1 times 4 and 2 times 7 are my options. I'm going to go with 2 and 7 because if I have negative 7 plus 2, that's negative 5. And 2 times negative 7 is negative 14. Okay, that's step 2. Step 3, set each part equal to 0. So I have x plus 2 equals 0 and x minus 7 equals 0. So I solve this, subtract 2, so x equals negative 2. Solve this, x equals 7. Those are my 2 answers. Okay. If you have any questions on examples 1 or 2, please write them down. Otherwise, we're going to move on to 3. First one, make sure it's all set equal to 0. This one is already done for us. Okay, so let's go ahead and factor it. There's no GCF, so I would just go ahead. What multiplies to 64 but adds to negative 16? 64 is 8 times 8, and if they're both negative, negative 8 minus 8 gives me a negative 16. Then I would go ahead, set each part equal to 0. This would give me x equals 8. This also gives me x equals 8. So how many solutions do I have? Just one, x equals 8. So graphically, if I only have one solution at 8, my parabola is only touching it at one point. This is opening up, so it's a parabola that looks like that, graphed. All right, example 4. First step, get it equal to 0. I always like to keep the x squared positive, so I have 3x squared. Move this over, I'd have to subtract. Minus 9x equals 0. Factor completely. Look for a GCF. I can divide both of them by 3 and x. So my GCF is 3x. So I'm left with x minus 3 equals 0. Step 3, set each factor equal to 0. So I have 3x is equal to 0 and x minus 3 is equal to 0. To solve for x here, I would divide by 3. 0 divided by 3 is 0, so one option is 0. Or add 3 to the other side, x is equal to 3. Those would be my 2 zeros of my function. Okay. Once again, if you have questions on 3 or 4, write them down and come and ask me. All right, moving on to number 5. Number 5, it's not equal to 0, so I'm going to go ahead and move everything over. So my x squared term is positive, so I'm going to leave it on the left. And I'm going to do it in order. I have a negative x here, so I'd have to add x to the other side. This is a positive one, so I'd have to subtract it. Equals 0. I look for a greatest common factor. There is not one. Then I will go ahead and I'm going to have to use guess and check, or you can use the box method, whichever one you prefer. I'm going to use guess and check. My factors of 6 are 1 times 6 and 2 times 3. So I like to start out with, like I said before, the ones that are closer. So I'm going to have 2x and 3x. And we are so happy when we're guessing because 1, the only thing that multiplies to 1 is 1 and 1. So I have 1 and 1. And then remember, for FOIL, to get the OI part, the middle part, this gives me 3x when I multiply, and this gives me 2x. Using those two, can I get to a positive x? If this is negative, so I would have negative, positive, and so I check. 2x times 3x gives you 6x squared. 1 times negative 1 gives me negative 1, and here is where it gives me my plus x value. So from here, I'm going to go ahead. I have it factored completely. Now I need to get my solution. So I set each part equal to 0. So I would first on this one subtract 1, so 2x is equal to negative 1. And then I would divide by 2, so x is equal to negative 1/2. Here I would add 1 to the other side. Then I would divide by 3, so x is equal to 1/3. Those are my two solutions for example 5. Looking at example 6, I want to notice that this is our difference of perfect squares. You need to get used to recognizing that one. Perfect squares. Because the square root of 25 is 5. So remember I set it up. It's going to be x plus 5 and x minus 5 equal to 0. Take each piece, set it equal, and we'll solve. So x equals negative 5 and x is equal to 5. Those are my two zeros for number 6. Number 7. It's a little different. It says write a quadratic equation in standard form with the given roots. It says think about what a factor that has a solution of negative 5 would look like. Okay? So what they're saying is these are my answers. Okay? Like these were my answers here. And they want us to work backwards to figure out what our original equation was. So the way I like to think about it is we really have x equals negative 5 and we have x equals 7. But we know we want to have 0 on this side, so in order to get 0, I would add 5 to both sides. So I would have x plus 5 is equal to 0. And here I would have to subtract 7, so x minus 7 equals 0. Now I would put my pieces back together. I have x plus 5 times x minus 7 has to equal 0. And from here, now I just need to go ahead and FOIL. So I have x times x gives you x squared. This gives me negative 7x. This gives me 5x minus 35 is equal to 0. If I combine my like terms, which we should, my original equation was x squared minus 2x minus 35 is equal to 0. Okay, that is it for 7a. Oops, sorry. Going on to 7b. It's only a little different. Okay, we have a fraction this time, so we're going to start out the same way. We would have x is equal to negative 1 over 3 and x is equal to 4. Let's do the easy one, the non-fraction. This gives me x minus 4 is equal to 0. Okay, I want to get this one to be equal to 0, but I can't just add 1/3 is equal to x. Or sorry, x plus 1/3 equals 0. We can't just do that because have we factored and seen any fractions? No. So the first thing that I would do is multiply by the denominator, which is 3. So now I have 3x is equal to negative 1. Now it's nice and easy. To get negative 1, I would just add to the other side. So I have 3x plus 1 is equal to 0. Now that they're both equal to 0, I can go ahead and say 3x plus 1 times x minus 4 is equal to 0 and FOIL. This gives me 3x squared minus 12x plus x minus 4 is equal to 0. Combining like terms, this is a minus 4. Combining like terms, I have negative 12 and x, so I have 3x squared minus 11x minus 4 is equal to 0. And that would be my original quadratic, okay, for 7b. Lastly, we have 7c. Okay, it says write a quadratic equation in standard form with the given roots. This time, they didn't just tell us what the roots are, but we just find them from the graph. We need to remember the roots are where it touches the x-axis. So it touches the x-axis here at x equals 0, and it touches here at 1, 2, 3, 4, x equals 4. So those are my two answers. So I have x equals 0 and x equals 4. Okay, this one's already set equal to 0. So I'm going to go ahead and just leave it as is. This one I need to get set equal to 0. I would subtract 4, so x minus 4 is equal to 0. Now that they're both set equal to 0, I take x times x minus 4 equals to 0, and I just distribute. X squared minus 4x is equal to 0. So this was my original quadratic. Okay. If you have any questions on the examples for number 7, please let me know. Please write them down, come and ask. Otherwise, we're going to move on to some geometry and algebra combined problems. Okay, so number 8. The height of a parallelogram is 4 millimeters more than its base. So when I read that, I'm just going to read it out. The height is in math means equal. So h is equal to 4 millimeters more than its base. We use b for base, and to be 4 more, it's addition. So it's b plus 4. That's my height. Then it says if the area of the parallelogram is, so area, once again, area is 221 millimeters, find its base and height. So I'm going to write that also down. So my area equals 221. And I'm also going to write down what I wrote down here. H is equal to b plus 4. So what I'm going to want to know is what's my equation to find the area of a parallelogram. So tools for success, we're going to need to know that. Here it is. Area of a parallelogram, remember, is just the base times the height. So remember on a parallelogram, it looks like this piece is my base, and your height is the up and down part when it forms that 90-degree angle. Okay, so area equals base times height. So let's fill in what we know. We know the area is 221. My base is, I'm going to use b, times my height. What is the height? It's b plus 4. Then I go ahead, in order to solve this one, I'm going to have to distribute. So I have 221 is equal to b squared plus 4b. Now I go ahead and notice that it's a quadratic. So in order to solve a quadratic, we get everything to one side. So I'm going to move the 221 to the other side. So 0 equals b squared plus 4b. I'd have to subtract 221. Now I need to go ahead and factor. I'm going to move my tools for success. All right, so we need to factor that. So I want to be saying what multiplies to negative 221 but adds to 4. Okay. This one might take a little bit of guess and check, but you could just start listing out your factors at 221. And you would find that 17 times 13 multiplies to 221. Okay, I need to be a positive 4, so it would be plus 4 minus 13. Remember to solve, though, we set each piece equal to 0. So this would give me my base is equal to a negative 17. This one gives me my base would equal positive 13. Can I have a negative base? No, we're talking about it's in millimeters. So my base is 13 millimeters. So that's the first part. Now in order to find the height is the base plus 4. So I would take the h is equal to 13 plus 4. 13 plus 4 is 17, so my height is 17 millimeters. Okay. There is example 8. Example 9, a little bit different. This time we're talking about a triangle. Okay. The height of a triangle is. So height is, remember, is means equals. So h equals 3 meters less than its base. So that means you take the base, subtract 3. So there's my height. If the area of the triangle is 44 meters squared, find the base and the height. So once again, area is, so my area equals 44. probably need to know the equation of a triangle. If you don't, here it is. Area is equal to 1/2 base times height, or it's base times height divided by 2. So what we're going to do is I'm going to set it up. So area of my triangle, base times height divided by 2. My area is 44. So 44 is equal to my base. I'm just going to use b because I see what h is. H is b minus 3 times b minus 3 over 2. This one is a little bit trickier because we have the fraction. So I want to get rid of it. How do I get rid of that fraction? I would just go ahead and multiply by 2 on both sides right away. So times by 2. So I have 2 times 44, which gives me 88, is equal to, those will cancel. And I know I'm going to distribute, so I'm going to do that right away as well. So I'd have b squared minus 3b. I notice my highest term is a b squared, so I know it's a quadratic. I'm going to get everything to one side, so I'm going to move that 88 over. So I have b squared minus 3b. I'd have to subtract the 88. And from here I need to factor. There's no GCF, so I know I'm going to just do b and b in the front. And I would say, whoops, what multiplies to negative 88 but adds to negative 3? This one's a little bit easier. 8 times 11 is 88. Would that work? Let's write it down. 8 and 11. To add to a negative 3b, well, 8 minus 11 is a negative 3b. So that's going to work. Now I set each part equal to 0 and solve. So I have b plus 8 equals 0. So b equals negative 8. And I have b minus 11 is equal to 0. So b is equal to 11. Once again, we're talking about a base, so you can't be negative. So base is equal to 11 meters. Now I need to find my height. Remember, the height is the base, 11 minus 3. So my height is equal to 8 meters. All right. So that is it for Unit 4, Video 5. If you have any questions, please write them down as usual. Come and ask. Otherwise, go ahead and work on the Unit 4 Practice 5 sheet. And have a good day.